solutions of an equation, solving the equation, all of that terminology is what we're going to use. Now, starting with our first example, all you are being asked to do in this section is to take words and convert them to numbers and symbols. Okay? That's what your example 1 is going to do for you. Just really quick, if I say sum, what do I mean? Go ahead. Good. If I say difference, somebody on the left, what do I mean? Good. If I say product, somebody on the right, what do I mean? Go. Bravo. And if I say quotient, somebody over here, David. Good deal. Now, sometimes they might say the difference of or the quotient of. I mean, all of that, that's what they're saying, okay? So don't get confused by any additional words that they throw in. So the first example that I want to give you is, and it's mine, remember your book has its own examples. The sum of B and 9 is 17. Okay, all we're doing is taking those words and translating them into some sort of symbols. Okay, just real quick, sum, product, difference, quotient. The word is means equals. The word is means equals. Okay, so whenever you see the word is, that is where the equal sign lives in your translation from words to numbers and symbols. So it's pretty clear that here's your is. You see where is? Okay. There's is. And whatever falls to the right of is whatever falls to the right of the equal sign. So is 17 equals 17. Okay? And I'm only circling and coloring for your benefit. Your homework does not have to look like that. The sum of blah and blah blah. So sum, you guys already told me means add, right? Okay. Sum is right here. And we've replaced the word with a symbol. Lastly, we're going to identify the things that we are summing. We are summing B and 9. B and 9. Okay? So pardon my silly color coding, but each piece of that properly grammatically correct sentence is now translated into a properly mathematically correct equivalent equation. Okay? So this here represents that there. We can do the same thing with every other operation. That just so happens to be addition. Subtraction might be and I'm just going to write difference of Z and 2 is 5. Okay? The difference of Z and 2 is 5. Did you find your is? Is. What goes to the right of is? Looks like the number 5. Are we summing or are we subtracting? We're subtracting. Difference. How do I know? Because they told me so. Now, some of you might say, well, how do I know? I know subtraction can be tricky. All they're saying here is the difference between these two terms. So Z2. Okay, they didn't give me anything weird, or there's some things you're going to see later on that might make it look a little trickier, but Z minus 2 is 5 represents the difference of Z and 2 is 5. How about this one? The product of 12 and K is 60. The product of 12 and k is 60. I don't know if you remember this or not, but we don't use the times symbol, that X, anymore. Because at this stage of the game, the letter X is a variable, and the X is also a multiplication symbol. It's kind of gotten thrown out, okay? So when you have a number being multiplied by a letter, the representation of that is simply to write them side by side. But let's really quick get our is out there. Is, our thing to the right of the is. And now we've got the product of 12 and k. You can do a couple of different things, but the most common thing that is done is you simply slam the number next to the letter. And it looks like this. 12k is 60. 12 of whatever this is 60. 12 times whatever that is 60. Yes, sir? A dot or a parentheses? Yep. So Justice says, how about this? That is also fine. You will also see this. And this. Any of those things are completely acceptable and mean the same thing. This is the common one. That's what you'll see. Letter D. The quotient of t and 5 is 11. This is another one where something has been made obsolete, and that is the little division symbol. You guys can go ahead and bury it out back because you're not going to see it anymore. Okay? Don't use that anymore. It still means the same thing, but you're not going to see it anymore. You will, however, see this. Whatever t is cut into 5 equal groups results in 11. Okay? Whatever t is cut into 5 equal groups is 11. You're not even going to see this anymore. Yeah, you're not going to see that anymore either. Okay? So here's what I'm going to tell you. Do not answer it this way. Okay? Definitely don't use that. Get used to this. Now, in contrast, something else I'm going to show you, the quotient of 6 and z is, guys, I'm just going to make something up, 54. That would be 6 over z is 54. Okay? The quotient of 6 and z. So the 6 is on the top, the z is on the bottom. Okay, there's my Z. All right? Yes. That's letter D. We've really crashed through pretty much everything. One other thing I want to share with you. And this is going to be example 1. I'm sorry, example 2. Is tell if 52 or 60 is a solution of what I'm about to give you. Something divided into 4 groups is 13, which in olden days, something divided into 4 groups is 13 would look like this. Okay, remember, I don't want you using this, but I'm writing it to continue to help you bridge from, 5th grade to now. In order to uncover what the dividend is, the easiest way to do it is to multiply those two numbers. Over here, it's to multiply those two numbers. Now, they've given you some choices, though, right? So I can easily test those choices. I can say, well, let's test the 60. 60 divided by 4. Okay, I've just plugged in one of the choices that they gave me. Okay, I'm testing this one. I'm pretty sure you can all do simple division. Probably nobody baffled by this. So is 60 divided by 4 13? Nope. We can assume the answer is 52, but we'll test it anyway. Okay, I'm just real quick doing that. So is the answer 52? Yes. So X indeed does equal 52. How do I know that? I just proved it by testing both examples in the equation of X divided by 4 is 13. I've just tested that. Okay? That is going to be your numbers 13 and 15. Last thing I have. Example 3. Solve with mental superpowers. Okay. Seven times what number will give me a negative 49? Well, I already know 7 times positive 7 is 49. But how can I get a number to make it negative? Xander?
When you multiply a positive number by a negative number, it makes it a negative number.
Very good. So Xander just said, okay, 7 works, but in order for it to be a negative 49, that G must be a negative 7. Does that make sense?
Yeah.
Okay, so watch signs. They are going to try to scare you with stuff like that. This is A. Here's another one. If I have 54 of something, and I remove some, and have 48 left, how many did I remove? Am I the only one that can figure this out really, really quickly? Hunter, what do you got? Yes. So 6 is your answer for H. All I would do is I would go 48, 49, 50, 51, 52, 53, 54. Maybe not in that tone. Letter C. Some number divided by negative 3 is equal to a positive 12. Go back to your rules with division and multiplication. When you are dividing two different signs, the result is negative. Okay? So what will the answer be? This is a tough one. Lydia, what do you think? She's right. X indeed is negative 36. I'm going to check her though. A negative divided by a negative indeed will work. Positive 12 times negative 3 did indeed give us that value, which is found right here. Okay, here's your value there.
Am I taking your students after school?
Same situation here. And that answer as well. Here's your last one. Letter D. 12 plus how many is 25? I don't know. Can anybody handle that? How much many must you add? How much many? Go ahead. Liz. She says 13. I don't trust her. 12 plus 13, indeed. So you are correct. Y indeed is 13. Okay? And I said under 15 minutes,